Welcome to qnawire.
Problem 7.43. We have this block of wood sliding around on a surface. The edges, sort of sides of it, are smooth and frictionless, but then the bottom of the surface is rough. Friction here with a coefficient of 0.2. And this is 30 meters wide. And this is starting 4 meters above the bottom part of this bowl or something, whatever it is. So we want to know, where does the wood come to rest, and what is the total work done by friction? So we know this starts off with no kinetic energy, and no work is done on it until by the friction, until it reaches here, and it'll already be at 0 meters. So if we call these points 1, 2, and then 3 is somewhere along here where it stops. So U1 equals K2. And in either event, this is equal to 78.4 joules, 8.4 joules. So now we know that the kinetic energy at point 2 plus the work friction does will be equal to 0, because that will be the kinetic and potential energies once it comes to rest. So our K2 minus mu m g d equals 0. So D is the kinetic energy going into the bottom divided by mu m g. And so it ends up going 20 meters, which is good because this is 30 meters long, and if this ended up being longer than 30 meters, we'd have to think about how it would go down here across the bottom and then up again some height, and then, we'd have to sort of keep track of which direction it was going when it stopped to figure out how many meters worth of bottom it's crossed. But in this case, it gets there before it even hits the end once, so no worries there. And then B, the total work that this friction does, it has to be equal to the total mechanical energy to begin with, or it's equal to the negative of that, because that's where all of that energy goes, is to the internal energy produced by friction.